guess we're there.
Sweet. Well, welcome anyone who's watching. My name's Hey Andy, and I also go by Nate. Uh, with us today, we've got Dave, Alan, and Andrew. The purpose of today, we're just gonna kind of shoot the breeze about the project, sort of in response to Dave's Christmas update. Kind of think about, what what are we here for? Kind of just thinking we'll see how serious or casual it ends up being. But I was thinking if you guys were open to it, we could just go around and do quick introductions. Like I said, my name's Nate. I'm a programmer. I think I came across Dave's videos searching something about artificial life, or I didn't know. I think you invented the term indefinite scalability, so that wasn't what I searched. It might have been something about like genetic algorithm or something. But I kind of hung around because it sort of piques my interest the same way something like Bitcoin does, where there's no central authority. So yeah, I'll pass it over to. Do you want to go, Andrew?
Sure. So my name is Andrew. I am a developer, web developer, also designer, kind of dabble in everything. I saw Dave talk actually a couple of years ago at UCSD. I'm an adjunct professor at the extension school, and kind of on a whim, saw his talk advertised and walked down and checked it out and kind of got really interested in what he had to say. And so I've been following ever since and eating up all the propaganda and wanting to create my own. So loving this chance too.
Sweet. Alan?
Hi, my name is Alan. I'm an engineer by trade. I really came to this through YouTube, actually. I think I was looking at artificial life as well. At that time, I might have stumbled on a video, and from there, I think something about the topic really resonated with me. There seemed to be finally an answer to a question I had about, how these systems that we're creating, how are we going to escape this trap of this system is fundamentally unsecurable. This system is very brittle. How are we going to create the next computer? So, from there, about 6 years ago, I continued thinking about this mainly out in my free time and just, trying to imagine another way and potentially the future of computing. So it's a very exciting and interesting project. So, yeah.
Yeah, you might be here on the ground floor, or who knows, right? That's kind of the nature of research, it seems to me.
Yeah, ground floor or only floor.
Yeah, right, exactly.
It remains to be seen.
Yeah, any other biographical stuff you want to add, Dave? Or
well, I mean, I feel like I talk about it so much.
Sure, yeah. You're the star of the show. That's fair.
I've been into computers my whole life. As sort of as soon as I encountered them, I fell in love. I did programming languages, wrote a C compiler as an undergraduate with a professor that I was working with. It was actually sold. It compiled for the DEC 10 for a lot of years back in the day. And went off to grad school and learned about this thing called neural networks and did some early work on this thing called the Boltzmann machine, which is one particular kind of neural network. And then went off to Bell Communications Research, the lab run by the local phone companies in the 90s. and where I had this great job, where my job obligations were to work on problems of my own choosing. So I guess I actually have to be clicking to switch this main video here deliberately. I kind of thought it would go automatically, but I'll try to remember to click it deliberately. Anyway, I worked at Belcor for 7 years, and then I went to the University of New Mexico, and I worked there for 24 years. And I did the genetic algorithms that Alan was talking about. I did all kinds of artificial life stuff because it was all in pursuit of trying to figure out how living systems and computational systems all connect together. And did a bunch of computer security work, biological inspirations for computer security. And that's when I kind of got really depressed because it it just became so obvious that there was really going to be no way to seriously make any of the systems that we had secure. And it wasn't because people weren't trying, it was because one bug was all it takes. And to claim that you're going to solve the last bug is just silly. But we're still dancing around as if that's possible. And so I got depressed. I didn't publish a paper for 5 years. I got in trouble with the department. And then around 2008, whatever it was, I got to the point of saying, well, there is a way that we could do better. But we have to give up on this determinism business. We have to have everything be random, everything's moving, everything is unique and one-off, and it only figures out how to get a good solid answer when it needs a good solid answer, instead of figuring out that we're just going to clear the decks and make everything be deterministic for start. And that's what led to the movable feast machine, which led to the idea of indefinite scalability as a way of driving the architectural decisions behind the movable feast machine, which led to the T2 tile project. And here we are.
Beautiful. Beautiful. Cool. Well, I have, and just to reiterate, we are seeing the chat. Seems like the latency is decent, decently low, that is. So we're watching. See Tyler Coleman down there, one or two other people. Pretty sweet. So basically, a full house is what I'm saying. It's standing room only here on the T2 Tile live stream. But Alan or Andrew, did you want to chime in with a question or a conversation starter? If not, I'm happy to toss one out there.
Okay. So like, I'm really interested in really like how did you come up with really, you know, the basic idea of the MFM? Like, where did this MFM come from? Did it come from the ether? You know, like you explained like what motivated you and you know to realize that, but like I don't know if that's a good starting topic, but
take a crack at it. Well, you know, cellular automata are a basic approach to artificial life since von Neumann and Ulam as well.
Right.
The idea of having a whole grid that's all updating rather than a single CPU that's controlling everything.
Yeah.
And a lot of the artificial life models that I had done research with were kind of like cellular automata. They were sort of more agent-based, but they were inherently spatialized. They were taking advantage of their local environment. And it seemed to me that if we're going to go beyond serial determinism, which, you know, that was what I came out of trying to do computer security and giving up, thinking that computer security was a lost cause, where we are now, that well, what's the alternative? If the alternative is not to have one thing controlling everything, the alternative must be everything going somehow at the same time and coordinating. Uh, um, and from there, the problem was, okay, well, we have Conway's Game of Life and these other kind of cellular automata, but they seem to me obviously equally fragile because every single transition had to be perfect all at the same time. Uh, um, so if we give that up, if we say cellular automata, but not absolutely deterministic,
Yeah.
that's really the key step. And everything else kind of followed from that. And then realizing that what you could get from that was indefinite scalability. I now sort of turned it around and pitched indefinite scalability first, but it came from artificial life, cellular automata, and asynchronous updates, having things that are going off whenever they go off.
Oh, very
Does
cool.
that
Thank
address
you.
it?
Yeah, very good. Good stuff. And yeah, just to clarify, we're, feel free to, follow up with other questions, your thoughts, Alan. We're kind of just making it up as we go along. So don't feel like you have to be locked into Q&A. But if you want to be locked into Q&A, then that's up to you.
We're not locked into anything.
Okay, no worry. I'm just messing with you, man. I'm just messing with you. Yeah, for sure. Andrew, you want to chime in there or?
Sure. Yeah, Dave, since you've spent so much time thinking about sort of like the MFM and how that plays into this, different way of computing, have you ever thought about like, well, were there other ways to approach it, or would you, I just imagine you've had so many more years to just sort of think about it, and would you go down a path that maybe was different but get sucked back into where you were in the first place, or are there any sort of I don't know, just options or other ways to think about it that you've explored?
Right. Uh, um, I don't think it's the movable feast machine or the highway. And so I do believe there has to be some bigger family, of which the movable feast machine is an example, that you could move around within this family without losing the key phenomena, the key abilities. And the example I want to mention is not actually my own example, but one done by a colleague, Lance Williams, who's also doing quite similar stuff, but he's actually coming from it, a bit more of a well, from my point of view, conventional computing focus. He would disagree, but he's the one that was responsible for the idea of compiling functional programming into distributed series of actors running on one of these grids. And the stuff he's doing now, some of which has been published and some of which is still new, is very much like the movable feast, but it's a slightly different set of rules. And my suspicion is that the model that he's using is part of that same family, or almost adjacent to the same family like that. And to me, the number one ticket is indefinite scalability. If you can show me how whatever you want to propose is actually going to scale, not just to wafer level, not just to data center level, but as far as it's going to go. And then we would measure its properties in the limit of imagining you had plenty of copies of it so that you had to pay for the communication costs off of each minimal unit you used on up the scale and so forth. And exactly how to frame it beyond that, I'm not sure. I still believe that indefinite scalability, if you take it strictly, uh, is really a pretty good razor for saying, is this architecture going to be admissible or not to this family that we're talking about?
Good stuff. Got a question from the chat. It might be I'm not 100% sure if it's similar. Hector Daniel says, what about the concept of cellular wave computing? Why not use this kind of computing?
Geez, I'm
I'm
not
not
sure
sure what
what
that is.
cellular wave computing is. Does anybody know?
No.
We would have to Google it, or Hector, you'd have to unpack it a little for us.
Yeah, and just following from the previous response, I guess question one, is it indefinitely scalable? And
Right.
that might be the answer right there, depending on
Right.
other question from Mycon. I feel like the first state for the T2 tile space will be some kind of primordial soup of atoms. What is your vision on what kind of system it will evolve into?
Mm. Given where I'm coming from, given my research history, the sort of really natural question is what will it evolve into? How far will it evolve? And on the one hand, I'm dying to find that out. But on the other hand, I'm trying to do the engineering without evolution. At the moment, the low level stuff, the transition rules, the Ulam behave functions, the splat rules, in my mind, they're really at the level of physics. They're really at the level of protons and neutrons interacting and sticking together if you get them close enough, whatever it is. And you really don't want the behavior of a proton to evolve. There's some stuff that you're going to count on to build on up above it. And so a lot of what I feel like I'm working on, what a lot of us are working on, is really at that level of physics where it's like, can we engineer stuff like a cell membrane or like a ability to create a state machine that can make decisions in some distributed way that's robust and so on. And if we can, then evolution is going to pop up at the next level above. Once we actually build protons and neutrons and molecules and cell wall and reproduction and so forth, evolution just happens. You don't actually have to put it in. In all of this process, I want to say the goal is computation that's useful for society. The goal is a new kind of super robust, scalable machine that can do system control, that can do lane keeping, that can keep your house temperature, curtains, whatever, uh, um, in some reasonable range of values for the as long as your house lives, not for until Nest gets bought by Google and shuts down all its servers and all the thermostats die.
Yeah,
Like that
or
would be sort of a
until the Chinese
profound
hack
layer
into
of
your
robustness.
Internet of Things
Exactly.
devices. Yeah,
Yeah.
or Americans. It could be Americans. I don't know.
Yeah, it could be, well, it could be anybody.
Yeah,
And in fact, the world today, it is everybody. Yeah, like that. So I don't know. I lost the thread.
no, that's
Did
good. Yeah, I think it was what essentially what
primordial soup.
applications. Yeah.
Well,
Hmm.
and
Yeah.
I feel like, and Mycon also asked also how large contracts will actually be for like usable programs. I had this question too, like, if these little atoms are sort of at the physics level, and we kind of have to get zoomed out a bit to start to see, these things build on top of each other. Like, I think I was trying to say this in chat. Like, I know it's pretty unknown to kind of really say like, well, at this level, this is where it starts to be useful. But do you have an idea of where you think that level is? Like how far do you have to sort of, zoom out on the
Yeah.
microscope to actually see something useful?
My feeling is cells. That once we have a cell membrane, an engineered cell membrane that has reasonably good properties, it's movable, it's robust, we can put lots of different things inside it and it'll keep working. That then we can go to the level we can when people think about object oriented programming, we would now start making the analogy that a cell is an object, not an atom, not an event window, but the entire cell represents one object. And it can communicate internally, it can maintain quite a bit of state. It's going to take a while. It's going to take a whole lot of transitions for a cell to respond to a message. But that's fine. I mean, consider how many assembly instructions a typical method runs when you do a serial deterministic method. So I think once we have reasonably robust cells, then we're going to have message protocols going between cells. And from there, it's going to be relatively flat. You know, living systems take cells and put them into tissues and put tissues into organs and so on. And yeah, we'll need that sort of thing eventually, but I think we can get to useful computation with just, so imagine taking a big, like 133 tiles or something like that, and filling them up with hundreds or thousands of cells that exchange messages with their neighbors, that develop a routing system, sort of like, you know, AJ's stuff, except at the cell level, and then continually has signals running through it. Like, here's the position of my right wheel. Here's the position of my left wheel. Here's the bump sensor stuff, all coming into this collection of atoms, collection of cells. And then decisions being made in a distributed fashion and saying, well, then turn a little bit more to the right, turn a little bit more to the left, whatever it is, like that. So I feel like once we get to collections of cells, we can start to recover programmability at the level that we just assumed it by force when we did serial determinism with assembly languages, like that.
Very interesting. Does anyone know how many cells there are in the human body? Probably.
They say
Like
trillion.
a trillion?
Of which like half of them are human DNA and half of them are bacteria, but we forget about that.
Yeah. All right. Yeah, a lot of the host. Yeah, right. It doesn't take many cells to do something useful, I think. I think that's a good way of thinking. It's building up the abstractions to nest abstractions and make sure that if you have some level of function in cells, you can scale that function up and achieve some higher level use out of that. Wow. So artificial life seems to be like very much important part of MFM, right?
Yeah, absolutely. And then the idea is that you can blow holes in this thing, you can destroy cells, and that's okay because just like city streets, if there's a pothole, you can drive around it. It'll take a little bit longer, but then the local cells can grow and split and fill the hole. And now we have two things that are tailored to whatever function the one guy was doing. And that's what I would just love to start seeing, where we get, you know, cell that differentiate into types. Like I'm connected to sensors, I'm connected to the wheels, and I'm doing distributed state machine stuff in the middle. And then, you know, if you start stressing the system, then it'll kind of automatically make more sensor cells to get the data faster or whatever, because there'll be a payoff to it because they're needed. And then you watch the system. In a way, the system is evolving, but it's evolving like a dynamical system evolving, not like Darwinian evolution, like that. But, you know, again, that's down the road. Talking to Hey Andy before we started the live stream, you know, it's like one of my problems is I really don't like to start painting these incredible, this could happen, that could happen in 100 years pictures. And I always want to stay as close to something that I'm sure I could implement if I actually pushed it through. But I recognize that the world is full of people who are claiming this in principle stuff that could be implemented in 100 years. So the stuff that I'm really willing to say I see how to get to seems kind of modest.
Well, we got a couple couple comments in the chat here. Good stuff, by the way. I think just my personal response to Alan, yeah, the A-Life stuff seems very related. Tyler Coleman, the MFM seems rather primitive programmatically. How do we expect to get to that? Or I'm sorry, we expect to get from that to evolving systems. Do we have precedent as far as evolving systems and software? And just in case these are related,
Right.
Joseph Collard, welcome. I recognize that name from somewhere.
Oh, hey, Joe.
I like the analogy of a chemical reaction happening in a beaker. Oh, this isn't a question. This is an observation. If you pour half into another beaker, the reaction doesn't stop. It continues in each beaker. JP, following on from the mention of object-oriented programming, how much do you guys see this stuff as a kind of evolution of object-oriented programming or object-oriented design, actor model, et cetera, or is it a different thing fundamentally?
Yeah, I think, you know, the fact that object-oriented programming hasn't gone away, even though it evolves over time, is exactly, is inheritance important or is inheritance evil? It's still called objects, that kind of thing. Speaks to the fact that there is something fundamentally right about having objects, agents, actors, whatever it is. So I think, and again, the idea of a cell being like an object, and again, tissues and organs being like large collections of objects that we'll get to down the road, is the right or a useful analogy. And the distinctions between agent, actor, I see as less important as long as we have something that's as real an object that we can. That the inside is not private just because the source shows private : It's private because it's in a dedicated area of space that nothing else can get to, like that. And you'd actually have to inject atoms and poke through the cell membrane to even see what was inside there. That's what private should mean.
Yeah,
but when we have objects in RAM, really, the instant the program starts running, objects are a complete illusion. It's all just addresses in memory. You can just walk right out the end of object and be in the next object like that. So I think, in a way, this approach, the spatially distributed approach, is going to be a more genuine instance of objects, a true instantiation of the object idea than what we currently call object-oriented programming in CPU and RAM.
Yeah, I was going to add maybe that. So, in partial agreement, I think it's useful to think about objects, but to me these are really ways of thinking about it. Like object-oriented design is a design paradigm. Object-oriented programming is a programming paradigm. I think the actor model is some paradigm of like actors sending messages to each other. Yeah. That's a useful way of thinking about the machine. I think if you spend any amount of time writing Ulam programs today, or programs for the MFM, you spend time thinking about how actors can talk to each other. So that is a useful way of thinking about. Yeah. And the message size is quite small, so that's a challenge too. How to gossip and send messages around. I think that's useful. The comment on spatial ideas is actually something I never thought about before. Is encapsulation in space is very useful.
It's literal.
It's really encapsulated. Unlike object-oriented programming, I think is just not so much. It's just really.
It's a metaphor.
For what the machine is actually doing, which is not like that at all.
Right.
Yeah, as long as the chain of dominoes, so to speak, works, and your super user bit stays at user and the group permissions are assumed, then you are okay assuming that they're separate.
Exactly.
But yeah.
Well, once again, but then you're back to the first bug and you're dead.
Oh.
Yeah, that was one. I don't know if it was illustration or analogy or example that resonated with me was, do you really want your passwords to pass through the same circuit as everything you look at on the internet? Or, password as a stand-in for anything you care about, health
Right.
stuff, financial stuff. And it's like, wouldn't that be cool if there were somehow a way those could be separate? And that was a really interesting idea.
Right. Yeah. And so I tried to say that at the beginning of the Path to Best Effort paper, where it's like, in the past, people thought this made sense, sending all of your information through the exact same place in space, and how we're just going to go, oh my God, what we're thinking. Once we get an alternative, once we get the engineering stack built up high enough that people can come into it and start programming at the level of cells, exchanging messages, and these messages are going to be big, heavyweight, slow things compared to the messages that I think Alan was talking about. From one atom to a nearby atom in the event window or close to the event window. That's going to be sort of microscopic signaling that would be part of this giant message floating by on its way to the cell membrane looking for a related guy like that. But then people are going to be able to think about it from the level of cells and intercellular messages and neurotransmitters and so on and so forth. And just as we do today, ignore all of the stuff that we're doing below it and just complain, oh, geez, message passing takes 3 milliseconds. Oh, I can't stand it. Like that, and we go, you're welcome. Like that at the end. So yes, absolutely. And I think at that point, once it's that obvious, people in the traditional computing community it'll be easier for them to get it. They'll be easier to make the mapping. I mean, we keep trying to make the mapping from what we already know to this crazy new thing. And we try to apply it to atoms. We try to apply it to bits inside an atom. We try to apply it to we try to apply it to the tile, whatever it is. But I think where we really want to apply it is to some sort of floppy cellular bag. And then we're going to go for primitives from there. So getting to a decent kind of a good cell is really the signal software achievement that we're going to try to get to once we have enough hardware that we can say, it's actually okay if this cell takes 10,000 sites of space, because 10,000 is a small amount of space in the way that we should be thinking.
Maybe someone is thinking this, but I think I would like to bring it up is, we have this technology stack that is very successful today, which is traditional, computing. So, I would say, why can't we build this at different levels of the stack? Why can't we build security at this level of the stack? Why can't we have physical security and separate things from each other to kind of, why does the MFM need to exist? I know someone's thinking it.
Yeah.
Before we hit that, can I pause for
yes,
a quick advertisement? Can we would you mind bragging about your shirt, Alan? Can we get that on the screen? We got the Alan is an early patron of the Andrew Walpole store.
Maybe Andrew wants to talk about it.
He's making it happen.
Rocks.
I think we should put a store envy link in there. They're great shirts, great quality T-shirts from Andrew. Thank you very much. They're awesome. Yeah,
they feed your cat for you.
I think people, it starts a lot of conversations. So
yeah, and that's great.
Great.
Beautiful. So yeah, right now they're being sold at cost. It's not funneling back into the project or anything. We've been vaguely talking about crowdfunding or something for tiles because there's a little bit of cash involved, but no hard plans. And got a quick question from the chat. Who are these people? Probably good to refresh that if you guys are comfortable with that before we go to the why this project exists. My name's Hey Andy, aka Nate. I'm just a fan. I'm a programmer. Andrew.
I'm Andrew Walpole. I'm a designer and web developer.
Hi, I'm Alan, software engineer by trade.
And this is Dave. Very cool.
Yeah.
So yeah, I just wanted to get that quick advertisement in before we dug into the big question, if that's cool.
Oh, why does the MFM need to exist? Is that the big question?
If we want to go there, we don't have to go there, but I think, yeah.
I guess.
I'm happy to go there. I mean, part of the problem is this idea of design lock-in, that when you make decisions in a computer architecture, you don't just make one decision at a time. CPU and RAM is not one or two architectural decisions, it's dozens. It's representing numbers in binary, it's assuming the bits are really good, it's assuming the memory is 100% stable, and so on and so on and so forth. And so the challenge is when you say, oh, well, we need to change this, we need to come up with a new approach. And you say, well, what are you going to do? You're going to say you're going to let RAM bits fail? And then what? The if statement might just go the wrong way for no reason. What are you going to do? And so the problem is, if you take just one little step, like say, okay, the CPU is going to fail every so often, or memory is going to fail every so often, you're in a position where it's absolutely clear the right thing to do is to fix that and go back to where you were. Make it so that memory won't fail, at least however long it takes to do whatever computation you can make money by doing. And so that's the challenge that I faced. That's the challenge that society, I think, has been facing since von Neumann. When von Neumann said, in a few years, we are going to come to a new architecture that's going to support the probability of failure of every component. And now we're 70 years later after that, and we're not doing that. So the reason, one answer is, the reason the MFM needs to exist is because we need to flip 8 or 20 design decisions all at once to get to an alternate approach that now pulls together on its own basis, instead of being a garbagey version of serial determinism. It's a great version of its own thing like that. Now, that's like telling people there's a new world across the Atlantic Ocean, and if you're just willing to take on scurvy and dying and whatever, you can go there. It's a big ask when no one knows if that's really true. So I see that. And that's one answer. Answer number two, and then I'll shut up, is once we build cells and membrane signaling and all this kind of stuff like that, we could, if we wanted, implement something like CPU and RAM on top of it. We could now actually say, yes, you could make a distributed CPU that exchanged all these things to decide what message to do next, and you could make a bunch of distributed stuff that would act like RAM, and it would, you'd send out a request by address.
Sure.
And it would come back and give you the contents of that address and so on. And it would be slow, but it would be inherently movable and robust and all these good things. So we could have what we currently are doing back, but it's been lifted up to this robust, movable level. And I think the reality is, once we get that far, we'd say, well, yeah, actually implementing DOS 3.0 is not the best use of all of those cells. We'll go direct to utility within the attractor of robust first computation instead of now using this platform to implement what we already had.
Good stuff. Good stuff. Anything from you, Andrew, other than visit mfm.rocks?
I think you kind of just touched on it, but just it sort of plays in my head like this idea that if well we come back to security as sort of the main issue, and rightfully so, for a system like this. But then you might have somebody make the argument and say like, well, I've got my calculator, it works quickly, and I pull it out of my pocket. And so like do you, I think I might be getting caught too, because you think about the distant future and you might think, well, a robust system like this that does have all those levels stacked on top of it, you don't really need to think about this question, which is, do we have both? Is that okay? Because it's reliable enough, even in its robustness, that you might as well have your calculator on it.
Right.
But until we get there, until you have so many layers that reliability exists in an effective way, do you see these things sort of needing to get along and needing to sort of say, well, let's go after these applications because security matters more, and you can keep your calculator in your pocket for a while.
Right.
Well, I don't know if there's a question there, but that relationship.
I put in a pitch again for the Path to Best Effort paper, that at least it's a weird thing, this paper, but I found it, so I put it up on the web for people to look at.
It's a really good read.
Thank you. But at least it takes a stab at, Andrew, your question, at saying, where are tiles, distributed first, robust first stuff going to get design wins in a world where we have zillions of traditional computers, and so on. And it suggests an answer to whether I think that's actually the answer that's going to happen or not. Who knows? But spoiler alert, a password manager, a secure password manager, would be that's what the story postulates, in effect. And the point is that, yes, you ask, can this movable feast stuff work along with conventional stuff? And the answer is yes, absolutely. But it works along via protocols happening at the edges. It sends messages, it receives messages, and so on. The idea that the stuff that's executing inside this is the same universal MIPS, ARM, x86 instructions as is executing in the other thing, that goes right out the window. But that doesn't mean that movable feast, sensory, robust control systems can't talk by interfaces, by message protocols back and forth with horrible, disgusting, not robust traditional technology. So that's the idea. And we need to get a killer app of some sort, enough that we can drive the hardware costs down so that we can have tiles like water. And at that point, that will be where you were saying, might as well have your calculator run on top of this thing because you're buying this stuff by the square yard.
Right. That makes sense. That kind of, you're kind of tying also into, so to like kind of get out of the future and all of that sort of presuppositions and stuff. When you build, for T2 tile, the next big thing is sort of, I don't know, do we settle on Lotus or Power Lotus as
I'm thinking Ring Lotus. I'm thinking the build is going to be a ring of lotuses, 7 lotuses.
So when you build that, what, not to fully jump ahead, but I will, what are you excited to do with that once you have that sort of
Well,
there?
for sure, yeah, just to stand it up and get it working is super petrifying enough. Uh, uh, but the next thing after that is I want to benchmark Dragon Res running on a Ring Lotus and say, we have now demonstrated 2 air, 3 air, 1.5 events per site per second across an indefinitely scalable grid. And if we decided to go back and make 7 more Ring Lotuses and make I don't even know what the next name would be, we would still get 1.5 air, whatever it is, because that's the nature of an indefinitely scalable metric. So that's step one, to draw the line in the sand. 1.5 air has been achieved. 0.01 air has been achieved. I don't know what it's going to be. We'll find out. I
Non-zero.
think
Non-zero.
yeah, exactly. That would be key. Epsilon air has been achieved.
Yeah.
The rest is up to the reader, like that. And so that's task number one. And then task number two is what I really want to do is what I'm better at, which is software, and get up working on getting to the cellular level so that we could take a Ring Lotus and use it to control the stupidest robot you ever saw, a giant platform big enough with car batteries to drive the whole thing. And then we could start virtually shooting holes, yeah, in the grid. I mean, they're a little expensive. To show how it behaves, how it works when you start stressing the system. And instead of falling over like every single traditional implementation will do, it's going to do surprising and sensible stuff, even if you knock out vast majorities of it, because the cells will still have enough to find a connected path through the hardware that's still there, and they'll send messages and they'll do what they can do. But even that, if that happens in 2019, we're doing great.
Right. Cool. So that kind of leads me to like the next piece. I'm the kind of person I always want to get to, like, if you have that vision for that future, how do we get there and draw that? So when you talk about these, these first cells, what's known and what's kind of unknown? Like, is there a place for us to start to look and poke at and start to find our way through that path? Do we say we want to build a cell that can do XYZ and then work backwards from that? Or do we just start playing at the elemental level and building a little army of things and then finding the bridge somewhere in between there?
And would it be okay to pause? And we got a little bit of stuff in the chat. Is that cool?
Sure.
Yeah.
So we have what to do next to head toward that vision with a pin in it.
Cool. We got David Newhouse in here, who apparently knows more about biology than I do, which is great.
Excellent.
A question from Mycon. Have you ever played with the idea that this kind of system could be developed biologically instead, since humanity is starting to fiddle with direct DNA manipulation, etc.? Tyler Coleman brings up the term wetware.
Right. Yeah. The A-Life distinction is hardware, software, wetware, hardware, robots, software, game of life, and wetware actually using chemicals, water, solvents, and so on. I think people doing wetware are extremely cool. But if you think dealing with Ulam is primitive, then try dealing with wetware. I mean, they're building cell membranes by using detergent and oil, that kind of thing. So it just snaps out and makes a non-polar membrane inside a polar solvent inside water, like taking grease out of your way. And which again is incredibly wicked cool. But I'm a software nerd and I want to get to the level where I'm programming. And so I think, yes, I want people to be working on the biological stuff. And also, yes, in the long run, if we can figure out sort of general principles of distributed, robust stuff, then those general principles will somehow find application in the detergent and oil wetware future like that. But I can't really contribute much to that, to the wetware side. It's just not my skills. And my ambition is based on, we've now spent 70 years figuring out how to put transistors and wires on silicon. And we can do it extremely cost effectively, extremely large numbers, extremely small. And the question is, how should we connect them up? Like that. So to take the existing technology we have for making silicon chips and say, all you need to do is use a different architecture and connect them this way instead of connecting them that way, then we can have a whole new thing. To me, that seems like an opportunity because now the world is full of extremely cheap 2D silicon gates. And what can we do with that? What was the other stuff?
That was good. And then I think, yeah, I just wanted to, it had been a minute since we had looked at the chat. Just wanted to get that one. And then, yeah, sorry to cut you off there, Andrew. You were asking something more practical about actually doing things, which I don't know why you would want to talk about that.
So what to do next? You know, the C211 cell membrane is out there somewhere, or the C212 membrane, the one that appears in the retirement talk and the one that appears in the A-Life talk from Tokyo this past summer. And that's where I'm going to go to try to flesh out this cell membrane vision. And really, once you start to understand how the C211 membrane is working, it really is a lot like oil and soapy water making little elastic things that just react completely dumbly. If the inside stuff pushes, the membrane grows out. If the inside stuff disappears, the membrane collapses back in, and that's it. And what I think we need is better stuff to put inside it that say, okay, we're gonna assume that a membrane like this is going to be our basic membrane to work with. So it's not like we say, do we need a better, stronger, robuster membrane or whatever? We're going to say, let's have the membrane be like this, and have figuring out what we need to put inside it, how the stuff inside it should behave, so that we can make the whole cell move. We can make it eventually split in a controlled fashion. The last demo we got before I switched from software back to all this hardware stuff was uncontrolled reproduction, essentially cancerous reproduction, where it's splitting all over the place. The next stop I would love to see is controlled reproduction, that somehow you drop an extra command atom in there someplace saying, reproduce now, and all the goo in the middle doubles up its count and segregates apart, and the membrane will just automatically grow and stretch around it. And if you pull it far enough, the membrane will just go, and now you have two, like that. It's about getting controlled the reproduction. Once you get controlled reproduction, you can totally have evolution if you want it. It's going to be hard, in fact, to avoid it. So that's what I think. The problem is, you know, the C211 membrane is written in splat. It's got a bunch of escapes to Ulam inside it. So you really kind of need to be comfortable with Ulam to even understand what's going on in splat. And, you know, it's only like 80 or 100 lines or something of splat, but that's a lot like that. So from one point of view, we need to build up the skill set. We need to get as many people who are comfortable with Ulam and then with splat. And it may, in fact, be possible to get comfortable with splat without getting comfortable with Ulam. And Andrew, that was something that was sticking in my mind about MFM.rocks, the idea of actually making a splat parser that doesn't have an escape to Ulam. It just has some built-in predicates and actions like you were talking about, that people could play around actually writing splat rules. And it would be super cool if people could get far enough to actually make a membrane I mean, a C211 analog in splat minus minus, like that. Although I think we would then find out that, damn, it's kind of running pretty slow on this thing, like that. But then it's no worse than MFMS. It's no worse than the simulator we have now.
Yeah, I think then as far as MFM rocks goes, like that's kind of my vision is I'm not super concerned about aligning it more with Ulam, though I think some things need to. It needs to, from a conceptual perspective, there's more alignment to do, but I think there's this opportunity to let people play with the concepts, and I think coming into it, like it took me a long time and a lot of watching your videos to like really get even like maybe like I'll say the concepts are kind of gelatinous in my head. They're not fully solidified.
Right.
But that's kind of good enough and fun enough that makes it really interesting. And so I think the idea there is to like provide a tool that kind of helps people with that in a hands-on way.
Right. Well, and I think it already is to a degree. And the more development they can do, the more sort of programmable or little mini, you can customize this element by clicking here or something like that, and then just see how the behavior changes, the better,
Right.
Well, so it's coming close to the top of the hour. Do we have other things that we want to try to touch on?
I think I'm okay.
Oh, sorry. I think we're doing great. I think some people are asking questions about like, how do I get started, which is kind of what you guys are talking about. I put the MFM Rocks link in the chat.
There's also an Ulam Lang wiki that has nothing on it right now, but stay tuned. I think I'm going to try to include some Splat and Ulam demos in there as I learn more of these things myself too.
Right. Yeah, to the degree that we can.
And after I get access.
I mean, all that I'm trying to do, which is new and outside my comfort zone, is to do all the development in public and to try to make the mistakes be public, make the discoveries be public, and so on, and let that be a trail of breadcrumbs, at least, in as a down payment for proper tutorials, people that know how to explain, to sequence these head exploding concepts that you really kind of need like 6 of them before you can really start getting it like that. Yeah. And all of these things, as somebody said, I can't remember that, maybe it was Andrew or AJ, that I've forgotten what I didn't get, like that. So the idea that that a site and a tile are 2 different things, for example, totally. Is not obvious from the outside, and the idea that the tile itself is really kind of an artifact rather than it's an engineering decision to even have a tile, is when given that that's what you see, it makes perfect sense that one's model would begin with tiles. I don't know. I don't know how to push that forward with 24 hours in the day.
I hope that basically the wiki can be a place to, disambiguate and learn basic concepts, and even like once we have more code examples and stuff and start building our library of atoms and larger structures, I think it would be really cool to have those stored in one place, and that could be a place for it. I would love to see like everyone having a place to exchange and contribute ideas. We have the Gitter, but building that up is important, like as a community.
I think so too.
It's totally new to me as well. I mean,
right. So write down your confusions. And so Where are we here?
Do we want to take one more question from the peanut gallery and then sign off?
Sure.
Okay. Well, thanks everyone for joining us. We're going to take one more question. Follow T2 updates on Tuesday. We've got the live chat on Gitter, just kind of an IRC kind of thing. Got the subreddit. We've got MFM Rocks. We got probably too much stuff that you can follow, but we're working on that. But this is home base. Final question for the day, Tyler Coleman. When people all have their own T2 system, do they connect up or have borders? I'm assuming he's at, if we're talking about like the internet and the boundary gateway protocol or something I mean, my impression was it was just like whatever, just add tiles and tile's a tile.
Right. And part of it is, again, how far in the future are we imagining? You say, if people have their own real estate, how do they join up at the edges? And it's going to be the same thing, because their own tiles essentially is going to be this computational real estate, and good fences make good neighbors. I mean, and to me, the thing that traditional CPU and RAM abstracts away, which is the fact that these things actually occupy space and something is actually next to something and not next to something else, is going to be where we're going to go back to answer these kind of questions. Yes, this part of physical space is mine. If I choose to fill it up with T2 tile computational fabric version 9 running my wacky physics, that's up to me. Now, if we want to have it connect at edges to somebody else's or some, public utility fabric or something like that run by the local government, well, then we'll have to deal with that. We'll have to figure out, impedance matching interfaces that different kinds of physics can exchange and so on and so forth. My fundamental goal is to say we're never going to offer pointers into our actual space. Everything that crosses a frontier, everything that crosses a spatial boundary is going to have to pass by message protocols. And if we then have some, zombie code word that someone can say to us that causes us to reprogram all of our T2 tile fabric to send spam or whatever, well, that's our fault. But it's not going to be easy to make that happen. If that's an answer. Well, let me say this. I think this was super great. Hey, Andy, Andrew, AJ, thank you so much for being willing to give this a try. Perhaps, we could do it again in a month or two or something like that. I don't know. I think it could be a helpful other thing. Maybe other folks who were in the peanut gallery would be willing to actually join in on the hangout and contribute face to face or whatever. I do believe that having the Gitter and Reddit and all these different things, which seem scattered, and it does make it is a bit of a barrier to entry. But where I'm coming from, it's much more welcoming than no entry, which is basically where we were. So that doesn't seem wrong to me right now. And the instinct of saying there needs to be one place where everything goes and so on, that's the urge to empire that leads to CPU and RAM. And you do want that, but you want it late. So right now we're trying to develop a lot of different things, the wiki and so on and so forth. Let things develop as they do, and let's learn from what actually does work and so forth, and then go forward to that. But I'm completely terrified about the T2 tile build, which is coming up, and all of these components that are in flight and so on and so forth. And I'm completely petrified that I'm going to spend all this money and then I forgot, oh, you have plus connected to minus and it's never going to work. like that.
That's when
the
we'll do the
language.
crowdfunding. No problem. We'll make it happen.
Yeah, that's why I'm not quite ready to say I'll take your money for the first build of the T2 tiles. If we succeed spectacularly, then maybe we could think about a second build, and people could sponsor a tile, or maybe we could even funding agencies might sponsor an entire ring or a lotus. And my idea is right, if for people that sponsor it, they could contribute a ping file that would show every time the thing boots up, where it currently says MFMT2, it would say Mycon or whatever it is, as long as it was in, not horrible taste. And if you buy a whole Lotus, you could have an Intel logo or whatever you want showing on the entire little spatial region that you sponsored. But again, we got to walk before we fly. Well, how about back to you? Hey, Andy, since you're our official guy.
I'm happy. Let's close it up. Thanks, everybody.
Thanks, everybody.
Thank you so much.
Thank you. It was great.
Bye.